So welcome back for the last session of the morning. I just received a message that don't forget that you can purchase the book of Marion Carré right at the exit and have it signed by the author at 12:15 once this session is over after the lunch, during the lunch. So now it is my great pleasure to welcome on stage Professor Anne Noé, Director of the AI Lab at the Vrije Universiteit Brussels, also Academic Director of FARI its inception, and she will be moderating the session on do's and don'ts for human, AI, and robot collaboration. After having had this first technical session, we will dive into what can you do, what should you not do in this great session. So the floor is yours, Anne. Thank you.
Okay, also welcome to this FARI conference on my behalf. We are indeed here in the second session on the do's and don'ts. And to give you broad perspective on this topic, we have a speaker from academia, big tech, and also public administration. So to make sure we give you the full view on these agents. And the first speaker is Tony Belpame. Okay, he's already standing there, ready to give his talk. I know Tony already for a long time because he also did his PhD at the University of Brussels. Today, he's affiliated to the University of Ghent, also to IMEC and Plymouth. But I give immediately the floor to Tony because he has a lot of interesting things to share with us.
Thank you for having me. So I'm an academic working now at Ghent University, just down the road, and I work on artificial intelligence and robotics, as if one wasn't hard enough. Now let's have a look at the world of robotics. Most people know robots as machines that manipulate the physical world, so robots that weld the cars together or that scoot around your house cleaning the floor. But increasingly, robots need to become social. For example, a self-driving car is a robot that has a physical job. It needs to take you from A to B, but it also has a social function. It needs to understand traffic. It needs to signal to other road users, for example, to a pedestrian, that it's safe to cross. Collaborative robots, robots that you work together with instead of being locked behind a cage, are robots that need to understand you and that you need to understand as well. And all the way at the far end of the spectrum, we've got robots that are uniquely social. They don't do a physical job, they don't clean your house or something, they don't make you a cup of tea. They're designed to interact with you using the same channels that people use to interact with each other. Now, a second dimension we can have a look at are where robots are deployed. And typically we find millions of robots in controlled environments, in factories, doing very predictable, repetitive jobs. But of course, we want to move away from that. We want to move to semi-controlled environments, so for example, warehouses where parcels arrive, but in a jumble, and the robot needs to pick these parcels up and put them in boxes or containers. But the dream is, of course, to move to uncontrolled, dynamic environments. And the most challenging one is our home. Each home is fairly identical, as in we all have a kitchen, we all have a living room, we all have a bedroom, but all our kitchens and bedrooms look very differently, and different things happen there. And dealing with that diversity is actually what we are trying to do now in academic labs. Now, we're making progress, getting there slowly. One big challenge, for example, is manipulating cloth. Why? Because clothes or textile always responds very differently. Now, every time you pick it up, it responds in a different way, but we're getting there. So this is an example from physical intelligence, where they can fold clothes, a standing challenge for about 20 years, and now we can finally crack this. Here's research from our own lab where we tried to pour a drink. Being in Belgium, it has to be chocolate milk, of course. So you shake the bottle, and then you try to find a glass and you pour a drink. This is a challenge, yeah? Not to us, but to robots, this is really difficult. Why? Glass is transparent, and just figuring out where something is and how full it is a really big challenge. We have spilled a lot of chocolate milk in the process of this research. However, yeah, these are all robots that don't involve people. And Rodney Brooks, one of the founding fathers of modern-day robotics, once was caught saying that almost anything interesting that happens with robots involves people. And I couldn't agree more. Now, building robots that interact with people is difficult. Why? Because the robots need to understand us, not only what we say, but what we really do. And we need to understand the robot. So if the robot is actually making a move, we need to understand why it makes that move and what it is going to do. A robot also needs to understand the world we live in, the values that we hold dear, what we don't like, what we do like, our preferences, our beliefs. The robot needs to understand the human world. And that is difficult because we need to create common ground, something that we all have. We all kind of, to a certain extent, understand what each of us wants, believes, desires. But for robots, this is particularly hard. And when we're trying to create social intelligence in the robots, the skill that we find effortless, we find that actually recreating that on a robot turns out to be really difficult. Why? Because it involves everything that our brain does. Every cognitive faculty of our brain, from memory to language to vision to planning to emotions, it all is at play. Our brain lights up like a Christmas tree when we are having a social interaction. And recreating that in AI is really hard. But we try, okay? Let me give you an example. Speech recognition. You're all familiar with that, and you might assume that speech recognition is a solved problem. Already about 10 years ago, the large companies providing commercial products said that speech recognition is superhuman, that it works better than the average person trying to understand or trying to transcribe a text or a spoken language. And that is kind of correct, but it goes wrong when you're dealing with atypical populations. Children, older adults, atypical speakers, people with a speech impediment. So, for example, children's speech is really, or traditionally was really hard to understand for speech recognition. I'm going to play you a sample of a 5-year-old boy telling a story to one of our robots. And the boy is very shy, very quiet spoken. You'll hear other kids screaming in the background. We're recording this in a school. And you'll hear a fan noise as well of the fan cooling the computer of the robot. Now, this is the point where I invite you to close your eyes and try and understand what this boy is saying. I'll tell you when to open your eyes again.
The dog is looking in the lens and cat is watching. The dog is looking into the jar and the kid is watching.
Okay, open your eyes.
Getting out.
That is what AI now can understand.
The kid and the dog is asleep.
Okay. This is really, really impressive. A few years ago, we couldn't do this. We now have AI that can understand atypical speech. Now, I don't know if you noticed something special about this boy's speech. It's English, and that is a problem because speech recognition works really well for English. If we have a look at a number of European languages, I'm going to point out English there, the smaller the bars are in this graph, the better speech recognition works. And for English, that is recognized better than any other European language. Here's Spanish, slightly better, and because we're in Belgium, here's French, followed by Dutch, right? You don't want to be speaking Estonian or Lithuanian because speech recognition doesn't really work for you there. And that is a problem. Right now we can understand English, but other languages we still struggle with, and let alone dialects. In Belgium, for example, we have lots of very, very colorful dialects. Speech recognition struggles with that. Now let's move to the other end of the robot interacting with you, speech production. I don't know if you've noticed, but every time we speak with each other, we change our voice to be understood. We speak clearly. A very nice illustration of that is the Lombard effect. So if you're in a very loud space, like in a bar, you are going to put more effort into speaking. You're going to speak slower. You're going to enunciate more to be better understood. And I don't know if you've noticed, but robots don't do that. Yeah? No AI ever changes its voice to be better understood. From digital assistants all the way to robots, none of these robots adapts to you, adapts to the human. And what should they adapt to? Well, actually, the noise in the environment, really important. A loud bar, you need to change your speech. The distance, if I'm further from you, I'm going to speak up. If I know that you have hearing difficulties because you're wearing headphones or because you have hearing difficulties, I'm going to change my speech. Your language level, if you don't speak my language, I'm going to change my speech. And finally, the acoustic quality of a room. If a room is very echoey, I'm going to change my speech. AI at the moment does not do this. And we've measured this, and we took AI voices into different rooms, houses, meeting rooms, the quietest room in Belgium, and we recorded how bad it was. How bad is it to actually understand AI under different circumstances? So let me just play you some samples of these words being spoken by a robot. And in the background, you're going to hear loud noise. Yeah? Try and recognize these words. Well, actually, they're written up there, so you should recognize them, but try and see if you would recognize them without those subtitles.
Juice.
There's nothing there, is there? Yeah? This is a default AI voice, the one that you hear absolutely everywhere. Now, we've changed the voice to be human-centric, to actually take the human into account when played over noise. Let's try again, but now this time with an adaptive voice.
Juice. Whip. Lord. Witch. Miss. Liar. Lose.
Much better. And this is what happens when the AI is actually human-centric, when it takes the person that it is talking to into account. Now, what can we do with this? Lots of wonderful things, but I'll give you a bit of a contentious example. We've been building companion robots in the lab. And why? The application really is combating loneliness. Loneliness is a problem that has taken on epidemic proportions. For example, in the UK, 1 million people go without speaking to anyone for more than a month. And that's not just, a bit sad, it has consequences. If you feel lonely, you have a higher risk of dementia and a higher risk of suffering a brain stroke. Why? We don't quite know yet, but it probably has to do with exercising your brain. Now, what we do is give robots to people to talk to. Yeah? Why do we do this? Well, because for many people there is no alternative. They don't receive visitors, they have no family anymore to talk to. And so we try and interact with them. We try to cognitively stimulate them using robots. This is a technical challenge as well as a societal challenge. Yeah? Really important things, for example, is that we want the AI to be empathic, right? A really big problem. Now, this is the context where we work. A care home in Flanders. This is Nicole. Nicole speaks French, and everyone else in the care home doesn't speak French, so she cannot talk to anyone. And she talks to our robot. She has an absolutely great time once a week talking to the robot. And if you don't believe me, let me show you this picture. She has a shelf in her room. This is a picture of her late husband, her firstborn, and Nicole herself, and next to that is a picture of her and the robot. That much does the robot mean to her. Now, let me just give you an example of a typical interaction. So this is Bertha talking to the robot about the good old days.
Wauw, het is een lange tijd om te voetballen. Hij moet vast veel mooie momenten hebben beleefd op het veld.
Ja, dat is waar.
Kun je vaak kijken naar zijn wedstrijden?
Ja.
Wat was het meest memorabele moment dat je je herinnert van zijn tijd als keeper?
Als keeper, als ik kampioen worden, dat was de schoonste tijd van dat ik mee mocht.
If you speak the local language, this is really, really hard for AI to actually understand and respond to. Now, people like this, they spend between 20 minutes and 45 minutes talking to our robot. And if we actually code for empathy, we see that there's a lot of depth in these conversations. It starts out by talking about the weather and things that are not too personal. After a few weeks, these people cover really deep topics, and the robot needs to show empathy. It doesn't really understand the empathy. Yeah? It simulates the empathy, but it's an important skill to have for that kind of AI. So where to from here? So if we've got these robots that now have social skills as well, what can we do? Well, I don't know if you've noticed, but in recent weeks or recent months, we've seen a whole kind of range of humanoids produced by about 100 different companies, most of them in China and the US. And I'm slightly, I don't know, annoyed by them. Yeah? They're bipedal, they can move around without falling over, which is a great achievement. So electromechanically, these are amazing machines. In China, they even managed to add boobs to the robots, but none of these robots have got a face. Yeah? And it really bothers me, because it means that these robots will not be able to connect with people. Yeah? Now, as we know, anything interesting with a robot, anything interesting that you can do with robots involves people. And so I really hope that in the near future, we're going to get robots that actually make that bridge, that connect the physical abilities that we're after with robots, together with the social abilities, so that they actually can really fit into our world. Thank you.
Tony, for this very inspiring talk with a lot of nice movies. So next I want to invite Alexander Sasha Venevet from DeepMind, who will give us another perspective on the topic. Oh, sorry, I was still looking for you to stand up. You will talk about things which are close to my heart, like reinforcement learning, multi-agent systems, but I also understood that you will be a bit critical, so that's very good.
Hello, everyone. It's my pleasure to be here. Thanks for inviting me. So I want to talk about living together with agentic AI, but also about living together as a society. And I hope by the end of the presentation, I will convince you that the picture of a paperclip on a polychrome blanket is relevant to the talk. So, let's sort of take a step back and maybe take a look at how our current wave of AI has arrived. So this is 2015. I just started at Google DeepMind, and this was the hottest thing in AI. This is an agent playing Atari game Breakout. Whoever played Breakout on Atari? Oh yeah, great, okay, oh wow, I mean, amazing. So you guys in 2015, you were probably excited all buying the Nature magazine to read up the paper. But I mean, I know that now this doesn't feel like AI, and it doesn't feel like what's so great about this. Obviously, a machine can play something like this, but back then, it was mind-blowing because the agent, and we already were calling them agents, managed to learn how to play this game without anything told to it other than that it can move the pedal left and right, and that there's a score and it's going up, and you want it to go up. And the idea back at the time was that that is the way we will get to AGI, or like strong AI. That we will just have some environment, we will have some agent that can do things there, and we'll just give it some reward and we'll follow it. And that's how we get to AI. So 4 years later, and I was lucky enough to participate in this project. This is Alpha Star. So what we did is we trained AIs to play StarCraft. StarCraft is who played StarCraft? Who knows what StarCraft is? Great. All right, a lot of people. So this is a complicated game. It's difficult. It's a multiplayer game. You control your little units, you build your base, you mine resources, and you want to defeat your opponents. And we sort of, it's still built on the same idea. We just give reward 0 or 1 at the end of the episode, whether you won the game or not. But already then we started to see that things were not actually working out as easily as we thought. We actually could not solve it without pre-training the AI on the recordings of human games. We had to start with human data. And that will come later in this talk. So what was this all based on? The holy grail back at the days were that if we just formulate the rewards, like winning the game or like moving the score of the game up, we can just make machines that will just maximize it without any assumptions sort of from first principles, and this will just solve everything. And the way to think about this this paradigm was, and about rewards, is that these were the way we would actually communicate to the agent what do we want from it. You might already think that this is a little bit funny. How often were you communicated what you're supposed to do by a discrete reward, right? Like, how did you folks ever learn how to sit in an auditorium and watch a talk? Did you have to come in a few thousand times, and then every time you did something wrong, someone would be like, no. Or like, oh, you sat and you were quiet. Okay, +1. I recently took my 2-year-old daughter to a theater show. Didn't have to do that. Just told her, you sit with me, we sit quietly, and that's what the audience does at a show. And that was the scariest thing, I guess, in the world of AI. This is how AI safety looked like back in those days. The worry was that if we misspecify the rewards, we would just what if the computer takes them too seriously and really pushes on and maximizes them without any consideration for externalities. So this is called the paperclip argument. If you create a powerful AI and you tell it to make a paperclip factory, it will turn the whole world into paperclips. And you can see how back in the day, when we thought that the reward is the way we communicate to the AIs what we want, this is somewhat a reasonable concern. It's like, well, I just define some reward signal. I don't actually know how it behaves in the whole space. So anything can happen, and then the game was okay, we will add other rewards that will specify the safety, and so on and so forth. And hopefully I won't turn us into paperclips. But something really changed when foundation models appeared, and you already heard the word LLM, and foundation model is just a slightly more general word for this kind of models, that it just means that it's not necessarily language, it could be images, videos, audio, whatever it is. And the way this technology works is you basically take internet, which is all of the digitized human culture, and you feed it through a deep neural network, and all you're trying to do is you want to predict, given the symbols that came before, what will be the symbols that come after. It doesn't need to be just linguistic symbols, could be audio, that's what came before, that's what comes after. It could be a movie, this was the frames before, the frames come after. And by ingesting all of the human culture, we suddenly arrive to what we all know as foundation models, whether it's ChatGPT, Gemini, Claude, or whatever that you prefer to use. And this is a very, very different paradigm, right? So what actually happens? How does it happen that we turn this pretty generic thing, which like, given these symbols, what comes next? How do we turn it into agents? How do we make it do things that we wanted? Well, we do it by we take this crystallized culture, this kind of like a genie trapped in a computer, and then we slice it with context. We give it the more context you usually give to your chatbot, the more specific and interesting the answers become, right? If you tell it, well, I'm going in Brussels, tell me what to see, it will just probably put you somewhere in the center of the town, direct you to a waffle shop. But if you give it more context, I'm such and such person, and that's what I prefer to do, these are my interests, and maybe, I don't know, this is my favorite artwork, it will give you more interesting stuff to look at. Moreover, symbols do not necessarily need to be just mere speech, right? They could be code, which could just immediately be deployed, could be API calls, tool use, it could be when you're operating a robot, some foundation models called VLAs, Visual Language Action Models, you can directly deploy them on the robot and they take sort of the sensory input, including linguistic commands, and directly convert them into action. So this is actually a very general model of behavior, right? And now we can define behavior in a very different way. There are no rewards here right now involved in this picture. So we can also try to communicate to these systems what we want from them in a novel way. So rather than specifying a reward function, we could use other logics of behavior. So in our group, we started looking around at other topics than computer science. Very rare for computer scientists to do that, but very helpful exercise. So for example, we'll look at the political science and the way they look at human behavior. It really struck us. They say the humans behave as if they're answering 3 questions at all times. What kind of person am I? What kind of situation is this? What should a person like me do in a situation such as this? So I reckon this is why you guys had no problems figuring out how to find your seat and what are you supposed to be doing during a conference talk, right? It's just there in the culture. We just know it. And if sometimes we don't, it can be just communicated to us in language. Let's spend a minute thinking about those questions. How can you even know the answer to something like this? Actually, all of these questions are quite vague, right? You need a lot of cultural knowledge to answer them. They're also impermanent. What my answer today might change. My answer today is one thing, but it might change tomorrow. What's appropriate in a situation for a person to do is different. And moreover, when you follow that behavior, if you break that pattern, you're likely to get sanctioned. So if instead of sitting down in the auditorium, you would come up to the podium and try to give a talk instead of me, probably one of the organizers would come up and sort of sanction you for that. Similarly, if I was just sitting there and not responding to Anne's welcome to come on stage, someone would come and be like, hey dude, come on, like, we gotta do that. So this observation is not only observation about the machines, it's mostly observation about humans. But given the large language models, we can, and like foundation models in general, suddenly this is how we can specify behavior to them as well. It's a very different way of thinking about things. So now if we're talking about do's and don'ts, I put it under the umbrella of appropriateness, and cite our paper where our thinking is summarized on this, is that the way sort of we get the answers to these questions is through our normative structures. So it's conventions plus sanctions. Conventions are simply behaviors that we do through the weight of precedent. You see others doing it, maybe you don't it oneself, you just keep repeating that. And norms are behavioral patterns that are supported by a conventional pattern of sanctioning. Once sanctioning for something becomes conventional, that starts supporting a norm that kind of regularizes our behavior. It's important that this is also a view of agency that is very socially driven, right? None of that stuff lives in anyone's specific individual head. Nobody had to learn it through a lot of back and forth and experience and kind of trial and error, and like, okay, now I know how to sit down in a restaurant. It's actually a lot smoother and a lot easier. So as I said, it's a different view of agency. So if the classic view of agent, and it's a different view of how society works. So if the classic view of individual agents coming together in a society, something like this. Like this. So we take a lot of individuals, they all have their own values, they have their own reward functions, or they have their own sort of goals and dispositions. Then we put them together in a society, and by their interdependence, they start kind of grinding against each other, and that's how the society forms. And this is the world of multi-agent reinforcement learning, and this is also the world of Homo economicus, all right? Rational actors in the market, all that. But we can also reverse that. We can say that actually, it's individual behavior that emerges when the society individuates and differentiates. So this is the view of generative agency. We have the culture, we have the society, and then the society begets an individual and their behavior. And of course, it's probably a feedback loop, right? I'm not trying to deny that there are certain things that are kind of, yes, I want to drink and I have some biological needs, of course, but even how I satisfy them is greatly culturally conditioned. Right, so it's not like that we sort of, by looking this way, we deny that there are incentives. No, they pretty much, the incentives can be there, and the goals can be there, and the rewards can be there, but they are sort of emerge there, right? Maybe just the answer to the question of what such a person, or it's a person such as I should do in a situation such as this, is, well, here you should be maximizing investors' return. In this case, you should be maximizing engagement, and in this case, you should be minimizing the leaks in the pipe, right? But that's not kind of God-given external thing to the agent. This kind of emerges in the social process. So why do we actually care to, like, how come we have all this normative infrastructure? How come we have all of that working? And the reason is that humanity is where it is because it's able to form stable, adaptable, cooperative groups. They're stable in a sense that they're stable as a group, but they're adaptable in the sense that the way they behave is always changing, and they manage to cooperate, sort of get forward. So when we are thinking about do's and don'ts in robotics, we now have agents that are also sensitive to normativity. If you try to sanction the ChatGPT, it will probably respond to that. They're also convention sensitive. They are already off culture. We kind of made them out of culture. So maybe we should integrate them in the same way as we are integrating each other into our social structures, by making them sensitive to norms and conventions, and adapting when working in the group. I think the important difference from the sort of reward first, or let's align everything to one vector of some sort of universal human values, is very well summarized by Richard Rorty, which is an American pragmatist philosopher that inspires a lot of our work. And what he says is, we pragmatists think of moral progress as more like sewing together a very large, elaborate polychrome quilt than like getting a clear vision of something true and deep. And so what we're saying here is that rather than trying to discover some sort of alignment vector of humanity and aligning the robots and AIs along it, this vector doesn't exist. We disagree. We're fundamentally in disagreement and always in conflict, which could be productive. But what we want to do is we want to minimize conflict, and that's what the norms are for. They're here, we create them to resolve conflicts. And it's never going to be one vector. It's going to be always a little bit different here, a little bit different there, falling apart at the seams, and we're always coming in and patching and sewing, trying to make it work. And we'll have to do the same with AIs and robotics. Thanks for your attention.
Thank you as well for this very inspiring talk, and I think it will sparkle some discussion. But now I would like to invite my third speaker, Francesco Rafael FARI, to have more the point of view of public administration on the topic.
Good morning. Thank you to invited me. I need to specify that I am only a bureaucrat. I'm not an academic. I teach, but I'm not an academic, so I am a bit emotional. And my job is to model, to plan, and also to manage organizations. So as we know, the organizations are a big group of people that need to collaborate, reducing conflicts, declaring goals. Without that, are not organization, but only group of people. And without collaboration, without the ability to achieve results, and also to evaluate these results. Emilia-Romagna is a more developed region in Europe. As you know, there are a lot of famous firms in Emilia-Romagna with 4.5 million of people, 600,000 firms, and a large network of technopoles and 4 ancient universities, other 2 universities, some universities from UK or United States and so on. The youngest one is 600 years old, and the oldest one is the oldest university in the Western world, so the University of Bologna. So the project what we show are realized thanks also to this university. We have the luck to merge a lot of computational power. You know, Leonardo is located in Bologna now, and we are waiting for the lease upgrading to Leonardo. But we have also Margherita. Margherita is dedicated to Margherita. It's 10,000 times less powerful than Leonardo, but 50,000 powerful than a normal desk computer. And it is a public cloud, entirely public, and it is closed too, so we can minimize the compliance because we can simulate all data sets that we want, also with sensible data and respecting the Data Act, Data Service Act, GDPR, and so on. We have an access also to a lot of public data sets because the healthcare system in Emilia-Romagna, but also schools, are public, entirely public. So that means that we have, for example, the depth of 10 years of 3D TAC, for example, of lung cancer, so we can realize a convolutional network about that, and training also our network, convolutional neural network, thanks for this data set, and also the availability of these data sets. And the first thing I would like to show to you, the first experience is Amartya. Amartya is a digital twin of the population of our businesses in our regions, and the name is dedicated to Amartya Sen, that you can imagine, and the scope of Amartya is simulate the inequality, the poorness, the child poverty, employment rate, in all consequences and all scenarios we can imagine in this situation. For example, duty. Our region exports a lot of things to United States. So for us, this international condition is very hard. And we can simulate and also geo-referentiate also the consequences across our region. Our region is, have a lot of inequalities because our mountain is higher than 2,000 meters, and only the 13% of the population lives there. The rest of the population lives in the Po Plain that is very rich and very connected. And so, for example, we estimate also the public spend of these policies made by the local authorities in our regions, and also evaluating also the distribution of wealth across region, across family, because it's a digital twin of firms and also families, we can simulate also the results of circular referment among firms and families, and also re-estimating the demand. And it is very important, and for that we need a high computational power. We can benefit from a lot of data sets, public data sets, also from the National Institute of Statistics, but also national ministries, but also business consultants that we use to formulate and to prepare these economic forecasts, for example, Prometheia. What we done, we realized this digital twin, and we, for example, we estimate exactly with a relative error of 5% of the purchase power of our families in the short and long term. For us, long term means 3 years, because we don't have the ability to foresee anything over 3 years. The second, this is a tableau visualization, the front end of Amartya, but we can have also other visualization, 3D visualization, animated visualization. This is a tableau visualization. As you say, you can vary also the conditions and like in what-if analysis of your premises. In Amartya, and also observing the map and where some phenomena can happen in the map of our region. Ultimately, Amartya is a sort of big automation. Now it's not a kind of generative AI, but we would like to inject in Amartya and large language or small language model in order to receive with natural language some order, and generally also machine code thanks to an LLM. The second experience I would like to share with you is the experimentation of co-piloting for 14 months in our regions with 200 managers of very different disciplines. So from the constitutional right to doctors, to urbanists, to economists, to everything you can imagine. Our organization is big, it's 7,000 employees, have 7,000 employees, so I was the employer of this organization until September, so I had the possibility to experiment and to use the people to, to make these experiments. And we found some empirical confirmation of all the theory we read. And we estimate also the return on investment of our experiment, because another thing is the cost that we need to take present. The cost of licensing, for example, will double if you adopt this technology. So we need to estimate exactly the ROI if we want to realize a sustainable implementation of artificial intelligence or foundational models inside our organization. So we found efficiency, innovation, and we foster collaboration among people, among offices, observing the results. And we observed, you can say, we made both interview to all the people before, during, and after these experiments, but also spying the people thanks to the data, thanks to the consent of the people, yes, but also observing the people. The first graph I want to share with you is that the co-piloting, the artificial intelligence is not useful for everything. For example, if you want to create something new, it's a loss. It's a loss of time, it's a loss of money. If you want, for example, to realize some new script with some Creative Commons inside, it's a loss of time. It is useful when you choose something where the partner and also the task is well defined, it is elementary. And also observing, in this case, the data of, and also the perception from the people, both data and the perception from people that used the co-piloting, but also Gemini in judgment archives, for example, the result is the same. If you want to generate new ideas, if you want to optimize processes, if you want to communicate with other people in order to collaborate with them, you don't need to use artificial intelligence. And this is a big result because the tasking is the elementary tasking is the principal benefit. So we can confirm in this sense the theory of Frey and Osmond. And this theory of 2013, before the arriving of foundational models, says that where there are the ability to perceive the organizational understanding and sense-making and sense-giving, the managers and in general, the human being is the best. And in this case, the artificial intelligence and the adoption and also the injection of artificial intelligence, the main task, can lower the performances of the people, particularly the people that have a resonance of performance, for example, and also uniform also the opinions of the people about something, and it is a danger. Another important thing is observing also the learning curves, and we observed also the learning curves correlating the ages and also the jobs of people. And also that is just interesting, but I cannot show all graphs to you. Thank you for your attention.
Also, hello? Yeah. So thanks to you for your nice talk and the evaluation you did. I have, however, one question. For me, it was a bit surprising to see that the productivity was one of the process optimization, I think was called, on your slides, that this was actually like negative. I would say it was like to the left-hand side. So how should we interpret it? Or was this focused on LLM support? Can you maybe comment a bit on this?
Yeah, no, the productivity could be high in, for example, 7% per day. If your task is very well defined, you use correctly this LLM in co-piloting, but could be also loss, for example, less 3% if you use co-piloting or if you use artificial intelligence, all the kind of artificial intelligence. For example, improving a phenomena called shadow AI, where the people without a guy from the vertex of the organization use artificial intelligence, other engines without the consensus of the organization. In this case, the productivity could be less, 3, 4, 5% per day.
Okay, thank you. So it was not like a dedicated AI system that would optimize a specific process. That's a correct understanding. Yeah, I think that's an important nuance in interpreting these figures. I also would like to ask the audience, or invite the audience to ask some questions. Is there somebody who would like to ask a question to our speakers? Yes, there's somebody over there.
Can I ask you to raise their hands?
There should be a mic. Yeah, it's coming.
There was a question over there. Over there. I already talked.
That was the sub-goal.
Thank you. Thank you all. Very interesting topics. I have a question about the topic of AI and loneliness, actually. You shared a very interesting example, Tony, about robots being used to minimize loneliness through some level of cognitive empathy. Yet at the same time, there's lots of criticism towards people using ChatGPT, for instance, to have casual conversations, like talking about their day or venting, instead of doing that through actual human interactions, and so encouraging loneliness. So I'm curious to know your perspective about these two sides of the coin, and how we as a society or individual users can, find that balance between AI being a tool to minimize loneliness rather than induce it.
So, really interesting question, and I don't have a good answer for you. Indeed, this conversational AI is a double-edged sword. On the one hand, you can do good, but there's this risk that people are going to over-rely and kind of draw back from having human interaction. And let me be clear, having a chat with a human is so much better than actually having a chat with an AI. But at the same time, there are occasions where it's better to actually, have a chat with AI first, because it feels safe to do so, because you can vent something that you wouldn't possibly be able to tell to someone else, to structure your thoughts, or because there is no social interaction available for you at all at this particular moment, then AI is valuable. And I don't know where this is going to go. We as a society will need to kind of figure this out. It might require some legislation. It'll require perhaps a new culture of interacting with each other and with machines, and we need to find a balance there. I'm convinced that we will find a balance. We always have, but probably we're going to go through a very rough few years before we find that balance.
Can I add something to that? I love what Tony said. I would just add that be very careful at using any of the chatbots as a mental health support. They were never trained to do that, and there is absolutely no reason why they would do a good job. And I think one of the challenges as well is that I think as we were designing these machines, the paradigm we had in mind was that they will be a little bit like a better Google, like a question answering things, and you have a pretty pretty well-defined problem you're coming to them with, and then just spit out an answer, and that's it. And if you have more than one if you have a follow-up question on more than one thing, is just because the first one kind of didn't really work out. But the reality is that a lot of people have back and forth with them hundreds, 1,000 times sometimes, and actually we do not train models like that. They're just not trained on multi-turn interactions at all, or most of our evaluations, most of our training protocols assume one question, one answer. So I think there's a lot to be figured out there. If you want to read something exciting, go on Reddit, My Boyfriend is AI, and your world will never be the same.
Thank you. Another question? Yes, I see your hand raised over there.
Thank you for the presentation. I have a question to Francesco. According to your graph, documents drafting and creation has negative index. At the same time, content preparation has positive index. I work in content creation and content management, and for me it's interesting what is the difference between document drafting and content preparation, because it can be almost the same.
For us, it's the creativity encompassed in some, for example, administrative act. So we cannot talk about the productivity in some administrative acts. It depends from the creativity of this administrative act. We can have administrative act where the task is very simple, for example, paying somebody. Or another one where you need to invent something new, and it is the different. Formally, we can say the phenomenon is the same. The phenomenon is the same, but the difference is that when there are creativity and the problem solving inside this act, the artificial intelligence could be an obstacle for us. We observed that.
Okay, I think we just have about time to have that follow-up question.
Thank you for your answer. So I have the second question then. If I have ideas and I want to discuss my ideas with artificial intelligence. Can my ideas be stolen by artificial intelligence? So can I make with my creativity, my human creativity, generative AI more smarter than, and can somebody use my ideas after?
Tony, you want to maybe comment on that?
I think that's more of a technical question even. It depends is the annoying answer. Yes, it would technically be possible if you kind of divulge really creative ideas to an AI system that the company behind it might use them. That all depends on the small print. So read that carefully. Pay for your AI. Don't use the free version, I would say. And if you're in Europe, I think you're in fairly safe hands. Your ideas will probably not be stolen, but I need to look at my colleague here. So there's not a single answer to your question.
I'm not an expert on that, but there are many different models. There are open source models you can run locally. If you're really, I think let's generalize it a little bit. I'm not sure about stealing creative ideas, but generally what happens with your data when you talk to AI, it depends. Read the small print. There's also many different ways you can interact with it. You can have an open source model running locally. You can also, even if you think about interacting with the same model, say interacting with Gemini from the chat and interacting with Gemini through the cloud API is actually different usage requirements and different privacy and the data own different. So if you care for that, you can do some research and you'll probably find something that will be satisfying.
And if this cloud is embedded and integrated and also specular to your organization. Because if it's specular and embedded in your organization, that could be a fostering of the collaboration inside the organization. If a solitary interaction, maybe it's another thing.
Okay, I see there's one more question. I see another hand raised, but we'll see how fast this one goes.
Okay,
Yeah.
Can I go for the question?
Yeah.
Okay, thank you. I'm a bit concerned how AI is moving to the social, and because some examples were about managing poor people with AI, attending elderly people, presumably people that are poor because they don't have family that can support them, and also Google, well, not paying too much taxes and becoming a multi-trillion-dollar company. So my question is, how are we going to turn this AI revolution into one in which people have more time to take care of their elderly and more benefits to the social?
Well, there's a small question. We'll need to write a few books on this because this is a really, really, really huge problem, isn't it? So how do you make sure that AI benefits all and makes us better humans? I'm doing my best, yeah, from my small little corner in a university. We try and build AI that is meaningful, that people find valuable, and we hope to lead through example there. But who am I? And it is, I think, the commercial interests are probably going to decide how things turn out in the end. And what kind of, how can we weigh on the commercial interests to make sure that those interests align with those of us as a society?
There are a lot of economists that faced industrial revolutions, and maybe this is an industrial revolution, the foundational models, not the AI. So when you talk about free time, I think to Maynard Keynes, for example. When you talk about upskilling, I think to John Stuart Mill, for example. So it's a big political question that I think now we are participating with the other 8 regions to a European call Gen AI for PR. The magnitude order of this call is 10 elevated to 6, is 14 million call. The agreement among OpenAI and AWS of the last week is 38 billions, other 3 magnitude orders. So we cannot compete if European Union respect the principle of competitiveness. We cannot compete if there are not a public company financed by the European states that can realize a big LLM public, like a public good. Without that, the distribution is impossible and the inequality will increase.
Thank you. We'll close the session, but of course we're happy to continue discussing this topic. After all, the FARI Institute stands for AI for the Common Good, so it's also close to our heart, this topic. The gentleman who had another question, I would invite you to come during the lunch break to ask your question to the speakers. I'm sure they will be willing to respond to your question, so I invite you now all for the lunch break.